Hello. I think we can get started. So enterprise DevOps at scale with AWS. So hi, I'm Jason Shawn. I'm the Senior Director of DevOps at Ellucian.
I'm Jesse Giggler. I'm a DevOps engineer at Ellucian. I've been with a company for 8 months and in the DevOps arena for 3 years. I'm also an active member of the PowerShell Northern Virginia user group.
Yeah, and I've done development for a long time, as well as operations, and now I'm in management. So there's that. Ellucian, we're a higher ed technology company. How many people have heard of us? So we have some employees here. Good. Essentially what we are is we provide higher ed institutions, ERP, CRM solutions, and some of our bigger products are Banner and Colleague and Recruiter. But yeah, it's, I think overall what we try to accomplish is trying to help students succeed and helping faculty and staff with their technology needs. So DevOps, I think probably a lot of you have been to a number of these, and there's a general theme that you've heard continuously, to borrow a pun. And the way we define it is pretty simple. Just basically people working together with a common set of tools and goals to achieve the best customer experience. It's not a marketing tool, despite what you may have heard in the expo. There's definitely tools and things that people are doing for DevOps, but overall it's just a philosophy. And really, for me, it starts with agile development, and that's kind of the groundwork that you start from. So going from the traditional waterfall model to something that's more in the Scrum or Kanban space so that you're actually delivering software in a pretty repeated fashion quickly and gaining a lot of feedback. So that's kind of where you start if you're going to go on a DevOps journey. And then I think the second piece of that is continuous integration, and that's where a lot of people really start the tooling aspect of it. This is how you build your software, test it, and then start to get to that piece where you deliver software into a production or a like production environment. So the next part of this journey is really continuous delivery. And so there's one thing that you need to keep in mind as you hear that term. So a lot of people mix that between deployment and delivery. In essence, what you want to try to accomplish from the beginning is being able to deliver software into production, so having it ready to deliver. It doesn't mean that you actually have to deploy into production right away, although that's kind of the next step that you start to take. But as you can see, really, DevOps is all about taking all of those foundations and building up to this huge feedback loop where you get down to the operations aspect and you're gaining feedback from the actual operations and the metrics that you gain or that you see from actual customer performance and how you feed that back into that whole loop. So as you can see, it's also about planning just as much as it is about development and testing. Okay, so did we mention that DevOps is culture? I think you've heard that in every single speech today, right? Because that is truly the foundation that you want to start with, is really trying to take those proverbial walls between groups and destroy them, right? And I think one thing that I want to call out in this nifty word cloud here is metrics-based. This is, to me, where the real great teams that are doing DevOps are focused. So they're actually taking metrics and feeding that back into their entire system, processes, their tooling, their automation, and they're really leveraging those KPIs and trying to continuously improve upon them. So one thing that I've heard in numerous talks and talking with people just one-on-one about DevOps is there's a fundamental fear that DevOps, while it brings about a lot of change, it also means that maybe, quite honestly, we're going to go and whack a bunch of people and cut our staff, right? That's really not what we're trying to accomplish. What we're actually trying to do is take people that are in traditional paradigms and really empower them to have more skill sets, right? So a developer that suddenly knows a little bit more about networking or databases, or somebody that's more on the operations side of the house, knowing and kind of empathizing with people that are software developers. So that's really fundamentally what you're trying to accomplish. It's not about taking staff and saying, okay, sorry, you don't have the skill sets we need anymore, you're out the door, and we're going to hire a bunch of young people from Silicon Valley that, do this stuff in their sleep, right? It's really about building those skill sets up and diversifying that portfolio, because that, quite honestly, is how you can give better value back to the business. You suddenly have more people that have a broader based skill set. You're always going to have specialties within this. But what we're trying to do at our company is we instill DevOps engineers into each group, and that actually builds those team skill sets up. So there's several developers or several people on the operations side, along with somebody that's kind of more of your traditional DevOps engineer. And that sort of helps build out that ecosystem within your different teams and really brings everybody up to speed. So if you're thinking about going on this journey, that's really a great way of achieving this and doing it at scale with a lot of velocity. So start small and build big, right? So this is kind of our mission statement: automate all the things, right? So you may have heard of people saying automate everything. And what is that about? It's about taking these small chunks and gaining small wins so that you can have these big wins, right? So taking things that might take just a few minutes, many of you might think, oh, that's not really worth automating, right? Why would I do that? Well, quite honestly, it's mental thought processes and it's things that you might forget to do as you're manually deploying software. It might not take a long time to make a DNS switch, right? And you might be entering that into your DNS server, but let's automate it so that that's something that we don't forget to do, and quite honestly, we can spend our time doing more high-value tasks. So that's really what you're trying to accomplish when you start to go down a path of automating everything that you can do. So I really like this graphic. I can't take credit for it. There's where the source is, but I think that this shows you exactly what's going on when you're thinking about continuous delivery. There's all these different elements that when you build it up together, it becomes what you're trying to accomplish from a continuous delivery standpoint. So you're going to see things like logging and metrics and building software, your actual source control. But you're also going to see things that, and this is why I like this, you're also seeing things like people and processes being in there. Testing, right? So one thing that we all do when we deliver software traditionally is testing's kind of that last thing that we do, right? Well, we want to shift that left so that we're doing that much more early in that process so we can get those feedbacks back to the teams that can fix those issues that are found. So definitely check this out if you can. So I wanted to kind of share what our journey looked like. So roughly in the beginning of 2015, we had cloud technology partners with David Linthicum, hopefully I'm not mispronouncing his name, come in and give us a score on our DevOps process. So we got a 0.0. I guarantee if there was a negative aspect to that rating, we would have gotten it. So we had a lot of work to do. Over the course of about a year's worth of work, we got up to a 3.5. Out of a 5.0 scale, that's pretty good. We still have lots of work to do, and quite honestly, it's always going to be a moving target, right? That's kind of the spirit of what we're trying to accomplish. But it's a good way of getting a metric. So what did we have before DevOps? We did a lot of lift and shift into AWS. I guarantee a lot of people in this room that have gone through this have done the exact same thing, leveraging it almost like it's another data center. Now we're doing a lot more of refactoring and trying to make things more cloud native right out of the gate. This makes it easier so that we can take advantage of a lot of these different AWS native services right out of the gate. So that's a big, big culture change for us, but also a lot of legwork to get that going, but lots of value there. Little test coverage, quite honestly, that's still a thing that we're struggling with and we're trying to get better at, but now we're much better, right? And we also, more importantly, have a way of finding out how much test coverage we have. Before, we really didn't have any idea, or if we wanted to know, it was kind of, pick up the phone, call somebody, and then, they pigeon messaged over to somebody else, and then finally you got the answer you were looking for, which you didn't want to hear in the first place. So also our security scans were completely ad hoc. It was essentially, hey, we're about to release some new software, security guy, can you please run a test? And then something bad would happen, and you'd have a person look through a PDF and say, oh, well, this is actually a false positive, don't worry about it. And then you'd actually find bugs and have to go fix it very late in the cycle, and that would make you potentially miss your date. Just not good. Now we've added a lot of security products into our actual pipeline, and that gets things going a lot faster. So we can get that feedback a lot earlier in the cycle. Before, we didn't really have a lot of CI. A lot of people sort of had a Jenkins server sort of tucked under their desk, but nothing really at the enterprise level, and certainly not anything that was at scale whatsoever. And quite honestly, almost no CD. And I think if anybody said that we were doing CD, they were probably kidding themselves a little bit. Now we're at about 1,500 jobs running daily. That's a big, huge step, and we have one central Jenkins master server and a number of slaves, and that continues to grow over time, which is a great problem to have. In fact, a lot of our Jenkins jobs aren't necessarily build-related or test-related, but they're actually getting into the more operations aspects, and Jesse will talk a little bit about that later in the talk. Also, our node deployment, so a new node that we would deploy into an AWS region literally took man weeks, so people on keyboards, and it always went bad. You'd always be riddled with problems. Well, just recently, we finished up a number of automation for a couple of our products, and we've reduced that down to about 4 hours, completely automated. Literally a person clicking a button, and that starts to kick off. A huge, huge win. Obviously, I think you can all mentally sort of put the dollar amounts to that kind of a win. So I'm going to kick it off to Jesse to kind of do a technical deep dive into our tool chain.
Thanks, Jason. So when we keep tossing around these words like pipeline and tool chains, essentially what we're doing here is we're automating a workflow. And that workflow in most DevOps arenas is how does code get from a developer's laptop into production? And so for us, that starts with the almighty source control repository. In this case, we use Atlassian's Bitbucket. A developer finishes his local testing using Vagrant and some of the other fancy tools and pushes that code into the development branch. Jenkins is pulling that development branch, or we're pushing it. It depends on the team. And then from there, we kick off the pre-bake. If anybody was in Corey's talk earlier, he talked a lot about pre-baking and how that concept applies a lot to immutable infrastructure, and that's something that we strive a lot for here. The pre-bake process throws in all of your app dependencies and as much of the application as you can. This is where you can enforce corporate standards such as BigFix and get those in so that the development teams don't have to worry about meeting those standards. It's all there for them in a Jenkins job, and we can have that golden image pushed down throughout the company. From there, once that pre-bake job has finished, it kind of starts off the deployment pipeline. We run a lot of our unit and functional testing with code coverage, and based on the success there, we will then actually turn out into the targeted AWS deployment accounts. So we utilize Terraform there to spin up the infrastructure, push out the code, Ansible for provisioning the servers and actually installing the application on top of that. And then from there, we run some more of our long-term testing, functional tests, regression tests, more security scans, and so forth. And then based on the feedback there, we either fail the job and create JIRA tickets automatically for teams to look in and do the investigative work, or we proceed with the build and promote it to the next environment. So we'll now be breaking down kind of the various pieces, some of the challenges we've found with them, and moving forward. So Jenkins, we've already talked about Bitbucket. I feel at this conference we don't really need to cover any more on that. Jenkins, we use this a lot as the orchestration layer. It's a really nice product to kind of glue together various aspects and manage the flow of jobs and processes. We utilize the EC2 plugin. Jason mentioned that we've got 1,500 jobs running daily. It's kind of non-trivial for a Java product to handle efficiently. So we spin up slaves as needed to process all the jobs and do the software deployments. We restrict each team to a folder in Jenkins. We tie that based on an AD group so that no other team has access to the other team's folders. The security Concerns there are mostly mitigated. One of the other things that we utilize is if you have just generic slave pools that all have the same instance profile, as we do across account deployment, there's nothing really stopping other teams from spinning up their own infrastructure in somebody else's account that they might not need to have access to. We utilize the CloudBees Folder Plus plugin, which allows us to constrain developers' jobs to specific slave pools. Those slave pools have a different IAM instance profile, which allows them to only deploy into the dev and test environments, leaving the operational slave pool with a different instance profile so that the operations team can actually deploy into production and provide a nice level of security there so that nothing goes into production without the process and approval. Packer to create the immutable infrastructure, so we're doing that pre-baking process. Immutable AMIs, ensure that all of our tools and components are included in the development lifecycle. Using Packer, you can set out users and accounts in Amazon to share them out cross-region and cross-account. So this makes it very easy for us to get those into all the other accounts that we manage. And then the new AMIs are rolled out by updating the launch configuration in Terraform with the new AMI ID that was pre-baked. And then Terraform for infrastructure as code. Everything else is code. Why not infrastructure? Terraform is a HashiCorp product. They do a lot of pretty nice cloud tools. One of the features of Terraform that we utilize constantly is the remote state file. This allows us to have kind of a layered approach to our infrastructure. The networking teams, more of the infrastructure-focused teams can push out best practices in terms of the VPCs, the networking setup, subnets, and then share all those values and resources through the state file via outputs. And then the application teams can build their infrastructure on top of that, and they don't have to know how to build the VPC or the subnets. They can just consume all the outputs from within the state file and deploy their infrastructure. We use the count, split, and element design pattern to scale resources. So if anybody's used Terraform, it's a JSON-based declarative syntax, and it seems pretty static and inflexible to begin with. But they also provide a lot of functions that, if used properly, can allow you to have a lot of dynamic attributes that you might not necessarily think are there. Those three functions allow us to pass in, for example, multiple availability zones. And then based on the number of availability zones that are passed in, we can scale out the environment to multiple subnets based on the number that are passed in. We do utilize Jenkins a lot to serve as a middleware wrapper around it to handle the dynamic variables. So we kind of constrain the developers to the 3 accounts that they can deploy into. They can select the SSH certificates that need to be applied to the instances, as well as determining the proper IAM role to assume in order to provide access into those accounts to do the deployment. And this also does allow us to remain cloud agnostic. Terraform supports multiple providers. These providers are a different set of infrastructure as service providers, so we could easily port all of our AWS resource definitions to Google, Cloud9 if the need arises. Ansible for configuration management. So Ansible, we use it a lot as a common way to provide server-level automation and infrastructure across our teams. So this way, if somebody's writing a playbook that installs Java, we can use that across teams. We're not spending time solving the same problems twice. We tend to try to keep the VPCs pretty lean and mean so that we don't have to rely on more traditional data center practices of managing and tracking public IP or private IPs. So we like to have the VPCs not interdependent upon any sort of VPC peering or other networking configurations. And to do this, we use S3 and the Amazon API kind of as a middleware that we can control and lock down and push playbooks into S3 from Jenkins, and then the instance or the user data of the instances gets that variable passed in from Terraform, and Terraform can pull down the S3 playbooks and kick off the installation of the product. And on the Windows side, we've been starting to use PowerShell desired state configuration to adhere to the same design principle. So a lot of you may know that Ansible doesn't run natively on Windows. So if you try to exec some playbooks in Ansible local configuration mode, that's not possible on Windows because you can't get Ansible server installed. PowerShell desired state configuration is a similar declarative syntax It's functionally a little bit more like Puppet, but you can still adhere to those same design principles where you can push, pull, or run PowerShell desired state in a local configuration. So we push those resources to the S3 bucket, download them on instance boot up, and then run it, and DSC can manage resources and life cycles past a reboot. So if you are adding a bunch of Windows features that need a reboot, it can handle that for you. Automated tests and unit scans. So once the code passes kind of more of the daily integration tests to make sure it doesn't break the environment, we kick off some more of our advanced feature tests, unit smoke, functional tests, make sure everything is happening. We use a Ruby gem to make sure that the infrastructure is described in a way that we expect it to work. Is the server running on port 3000? Service spec will kick off a test to do that for you. We have started to investigate Posh spec, which is a port of that for the teams that are writing a lot of their on the Windows platforms, so they have a more familiar language that they can do that in for just faster results. And then we proxy these results through a Bastion server back to Jenkins for reporting and tracking. So this way we can get that feedback into the Jenkins pipeline so that we can fail the build or notify the teams appropriate so that they can remediate or fix any bugs that might be discovered through the tests and scans. Challenges and pain points. So as we've talked about, that we have a pretty big account footprint, maybe not as big as some other teams, but we're thinking about like 120 accounts. So the cross-account deployment lifecycle is pretty tricky. We have a centralized AWS account where our DevOps pipeline lives. This is where Jenkins and some of the other tools live that help the developers do their deployments. So we have to do a lot of role management with IAM. Like I said, we use Jenkins as kind of a middleware wrapper here so that the developers can only select certain roles, and we constrain those roles to the slave pools that they can use. So this limits which accounts that they can push into. And we set like a drop down of a predefined list for them so that they know, with just based on the targeted account and friendly names, which role to assume to deploy into the accounts that they need to. Resource tag management, lots of teams, lots of resources, lots of accounts. How do you keep track of it all? We have a centralized billing account, and we push this cost center tag down to all the instances. This allows us to charge the individual product teams and groups and provide accountability for tracking of resources. So this way somebody can't max out C4X large and then not have to worry about picking up the tab for it. So we utilize Netflix's Simian Army, and in particular the Janitor Monkey. And this allows us to define rules for our infrastructure and scan the environment to make sure that these rules are met. So in this example, one of them would be the cost center tag. Janitor Monkey's out there keeping a constant scan of the environment, and we can search for that rule and make sure that everybody has a valid cost center. If not, we can set and vary the rules so that the instance is deleted or the other resource configurations get deleted as well, so that we're not incurring cost and people are adhering to our corporate standards. Resource tag flowdown. There are some elements in Amazon that do not copy the tags from their parent items. So this is kind of a problem. If you take a snapshot of an EBS volume, those tags do not get propagated down. So that's kind of difficult to track, because then you have to have somebody manually going back and figuring out where those snapshots belong to and whom to build for them. So we've come up with a resource tag flowdown script. It's a custom Lambda function that regularly scans the environment and identifies any untagged child resources of a particular type, finds and resolves their parent ID, and then applies those appropriate tags so that we have accountability from a cost perspective. As far as soft limits go, I'm sure most people here who have more than one VPC have figured out that the soft limits are quite aggressively low, for good reason too. We use the Trusted Advisor check results to periodically scan and test our current usage against the current limit. So we have this in a Jenkins job. Depending on that limit, if it doesn't return green, we funnel that back into the AWS support API, automatically open up a case, and then we'd kick off an alert to PagerDuty to notify some of our operational engineers that, hey, this might be a problem. A deployment might be blocked because we hit a resource limit. Here's the case number. Let's hope everything gets resolved pretty quickly. Scheduling for cost optimizations. I mean, the cloud's very cost effective, but you have to set it up. We make a lot of use of the auto-scaling group's scheduled actions. So this allows us to set business hours for the most part on our not a non-ephemeral, but our less utilized non-production environments. So this allows us to say the developers are only going to be in from 9 to 6. We run that environment for that time, and then we have a scheduled action that brings down the environment. We also have a couple of teams that just schedule a Jenkins job that destroys their entire environment and then brings it back up during the appropriate business hours. This cuts costs by having your resources not running and incurring charges for about 2/3 of the day. Emerging patterns. I'm going to hand it back to Jason, because at his level, he has a little bit more visibility into some of the patterns that happen.
I don't know about that, but all right. So how many people have heard of blue-green deployment? All right, look at that. Good. So obviously, then that means that it is an emerging pattern. So there's more and more people doing what essentially had been known as like an A/B switch a lot. Back when I was a developer in the Stone Ages. I did these DNS switches, right, where you would test sort of your new code and do a DNS swap and flip everything over. Well, now things are much more sophisticated. You can leverage some AWS native tools to do this. But there's a huge movement to essentially have your new application rolled out to a customer at some percentage where you're actually letting real live customer traffic start to touch this new code. And then based off of how that interaction works, you can either do it from an operational metric perspective, meaning, so I'm not getting a bunch of 500 errors, so obviously this new release is good to go. I can then flip to the new release. Or maybe you're looking at it from more of a business metrics perspective, and you actually set up some metrics on your back end to see how many orders you're getting or registrations or whatever it is that you're trying to accomplish. So this is actually something that Netflix and Amazon make a huge amount of use of, and it's something that I think fundamentally has changed the way that we can do software development. Back in my day, I remember launching applications, and we'd find out something from the business side. Suddenly sales are way down, and we would have that panicked 3 a.m. call where we would all have to scrum together. We didn't even call it Scrum back then. And we would figure out, okay, this is the issue, let's roll it back, right? And essentially that was our option. We would roll everything back, and we would take outages to do this and downtime, and quite honestly, you would just have a wretched customer experience. And so now that we have this technology that allows us to do more of these tested sort of deployments, it really has changed and moved the needle for everybody from business owners to software developers to people in operations. And I think fundamentally that's something that if you're not looking at doing that today, you should really start to look into how you can accomplish this. So one of the things that we want to do is always eat our own dog food, right? So our own environment, our own pipeline self-heals itself. So we have some CloudWatch metrics that look at our Jenkins environment as an example. And if something is awry, it will start to self-heal itself, right? It'll start to take a snapshot and rebuild itself, tearing down the old environment and bringing up a new one. I think that's a good way for teams that are doing DevOps to be able to say to the other teams that are sort of adopting their pipeline, you can say, look, this is what we're doing in our environment, and start to think about how you can do this for your own application. But yeah, so essentially, I think self-healing in general is a big pattern that we're seeing emerge more and more often. Certainly, again, the Netflix and Amazons have been leading the charge here, and fortunately for us, we all get to reap in the benefits of their R&D teams doing these sorts of things. I think fundamentally that's a huge shift for the CI/CD culture as well. And so DevSecOps, this is a big thing now as well. This is sort of like a quick snapshot of what we're doing. But DevSecOps, I kind of like to think of it as putting the cops into DevOps, right? So this is what's going to look over your environment and make sure that everything's hunky-dory and that you don't have potential cross-site scripting issues or other SQL injections or other things like that. So we leverage a number of tools to actually accomplish this. But I think the thing to kind of glean from this particular graphic here is that these tools start to feed things back into ThreadFix, which then makes its way back into our team's backlogs. And that's an effective way that I've seen manage this whole process, as opposed to it sort of coming down from management where someone says, hey, I just heard that you have all these flaws and what are you doing to remediate it? You can kind of get that feedback more instantly in the hands of a developer, and they can start to look at things and say, oh, no, actually, you know what, this is a false positive, or oops, I didn't do this correctly, let me go and fix this issue. And it kind of gives you a little bit better way of getting some insight into some of these challenges. But yeah, so I think this is definitely a newish space. I think companies like Evident.io are certainly emerging as a company to kind of go to do these sorts of things. And I think, quite honestly, this space is going to just continue to explode over time. So with that said, we were hoping to leave a few minutes for questions if anybody had any questions. Go ahead.
You mentioned you do a few things with Jenkins that was unique. What are the things you're doing with Jenkins?
Got any?
I think we covered them on the slides with the controlled slaves, where we're restricting which projects can run on which slaves, and that allows us to therefore constrict the IAM profile that they have access to and kind of neuter it down to the dev and test counts and leave production untouched until that's from the actual cloud ops team.
Yeah. Another thing is that we have a pretty good relationship with CloudBees, and I was meeting with them not too long ago, and one of the things that they're seeing other customers do, and that we're starting to kind of do more than just dip our toes in, is kind of looking at things from an operations perspective. So, Jesse sort of touched on the whole idea of looking at soft limits and then paging us if we see, from a trusted advisor API call, suddenly we're about to get constrained, right? So looking at doing more of those sorts of actions and then hooking it into like your PagerDuty or whatever your paging source is, to be doing sort of these tasks that a lot of ops guys used to do. And so I think, honestly, what we're going to see more of with Jenkins is more people that are kind of on that bent, leveraging the tool for their sort of repeated tasks, if you will. So good question. Anybody else? Everybody's super psyched for the reception.
I have one more.
Go ahead.
So some of those slides have a lot of different technologies on. Right?
Yep.
How much of your guys' time do you develop, you spend like on a monthly basis trying to understand even new emerging technologies and whether or not they should replace something versus, like, how do you balance that?
Okay. So that's a great question. So we do try to spend, so my team is the DevOps core team, right? So we manage the tool chain, the pipeline. So that sort of stuff kind of falls under our purview. But we also have a dedicated applied research team as well that does a lot of this kind of stuff. So they do a little bit of these sorts of things, especially right now they're doing a lot of things with container technology, right? But I would say from my team's perspective, what we try to do is adhere to kind of that notion of an 80-20 split, right? So 20% of our time is spent on tech debt or research or some sort of thing where we're maybe greenfielding some new product. I think one of the other points maybe you're trying to get at as well was how much time does one have to spend learning these new technologies and managing them? Honestly, I think the thing to kind of keep in the back of your mind is no one's going to be an expert at this, and a lot of these things are going to change like this. So it's almost like, what's the point in mastering something if it's just going to change, right? So I think the thing that you see is it's more about the fundamentals of what you're trying to accomplish that should be what you're focusing mastery on, as opposed to the actual technology or language or DSL, if that's what it is.
That makes a lot of sense.
Okay, great. Great. Yes, sir.
From the time a new project starts to you have a fully fledged operational pipeline, about how long is that?
For an individual team, it could really vary. It really depends on how big of an application they are. If they're a new app, tremendously easy, right? We're talking maybe weeks at most, and that's a hard one. If it's something that's more of one of our mammoth enterprise, we like to call them battleships, applications, these are applications that have been built upon for 20 plus years, right? These take a tremendous amount of time. I mean, a large team, our banner product, as an example, has been undergoing its sort of DevOps adoption process for, I think, roughly 8 months now. And the plan is to have it done right around the end of Q3, and then we'll start pushing new installations of it through our pipeline into production by the end of Q4. So it really just depends on, I think, the scope of the application. I think web apps, traditionally the 3-tier kind of web app is pretty straightforward, but it's when you start to have the myriad of tools.
Yeah, I'm not talking about training people, but like somebody who's already used to your sort of system, they say, we're starting a new project today, spin us up a new pipeline.
Oh yeah, so that's relatively automated. So essentially it's, hey, I need a new project, so give me a Bitbucket project, boom, it happens. The Jenkins folders get created, and then they can start kind of getting some of that stuff. Some of the stuff that we still need to work on are around like AWS credentials and the IAM roles and some of those things. But yeah, absolutely, I think that's essentially the goal, right, is to have it turnkey so that somebody could just say, it's almost like the old IDE stuff where you would have sort of a template of an application that you'd start with.
So you do it like hours? Or?
Oh yeah, in that case it would be hours, absolutely. Yeah.
Do you automate the Jenkins jobs, like actually creating those jobs, like with job seed, like Ruby or something like that?
I don't think we're doing
We've got
that.
a fairly big mix. We've got one team that's using the Groovy job seed stuff pretty heavily. We're also starting to utilize the pipeline branch mode so that as developers fork their repos, it automatically creates those jobs for them and gets them into their templates. So it's a pretty mixed bag, but that just depends on kind of the where the development team is in terms of their skill set, expertise.
Yeah. Yeah, I think one thing I don't think we touched on was one of the challenges we had was we were trying to drive a standard set of tools, and I think inevitably whenever you do that, there's going to be some inefficiencies, right? Some team's going to be using a type of setup that's not going to be as easy to leverage. Jesse touched on, Windows applications and the challenges with Ansible. I think notionally what we were trying to strive for is to get as many people to a common set of tools as possible. That way, it becomes a lot more fungible, and you can scale better.
You were saying that when you had, say, a Jenkins job go bad or something, it would self-heal by stopping it.
Right.
A new one. That sounds a whole lot like rebooting Windows 95. I think it wouldn't work very often. You put back exactly what you have and do the exact same job over again, but generally you're just wasting time. Why is that an effective way to work?
So, good question. So I think what we're trying to do there is take a snapshot when we detect that the CPU's high, right? So it's kind of a snapshot in time, and then what we do is in the background start up the new process. So instead of a bunch of teams starting to hit like CPU limits and they're completely throttled and they can't do anything, we start bringing up the new environment so that amount of downtime from a Jenkins perspective is relatively limited.
Just going around the problem so that people aren't held up.
Okay, I guess. Go ahead.
So there can be a lot of tool overlap, like Ansible, you can use it to provision as well as configure. How did you guys draw the lines between which tools were doing what?
Want to take that?
Sure. I think that was just to kind of what fit best for our needs in terms of the paradigms that we wanted to stick to. So we're trying to stick to the mutable infrastructure concept, and so having like a centralized Ansible environment in which we would need to deploy the infrastructure and then configure it as well. It seemed a little bit easier to do that with Terraform for infrastructure as code and to persist that state file, whereas I believe the Ansible tools that I've worked with that do infrastructure provisioning don't necessarily persist that state. And so it kind of, we found our way into it a little bit organically where Terraform fit the bill because we could persist those values in the state file, and then the product teams could consume them. And then we had the Ansible was a good choice for us because we were able to use that as a centralized way for teams to like share their resources and the work they've done instead of the ad hoc bash scripts. So it was just kind of like an organic piece that just kind of fell together, and we're like, oh, it fits, let's run with it.
So a lot of what you know that I've seen in this seems to be geared towards developers and not the operations folks. You all have a pretty big footprint in AWS for running servers, like probably your hosted stuff is there. SaaS stuff that's coming up is probably going to be hosted.
Right.
Are you working with the operations people to deploy their servers the same way?
Yeah, absolutely. In fact, the operations people do a lot of the infrastructure as code pieces. You know, they're doing Terraform to build out VPCs or manage networks, in fact. Yeah.
Okay, so this all matches exactly.
Yeah, absolutely.
So wait, you still have your development and operations teams like separate though? Like what I gathered is you have ops doing your production deployments and you have your development team basically.
In many cases, that's still the case, and that's something that we're working to rectify, absolutely. But yeah, in some of our newer teams, that's totally not the case. But I think over time, you know, more of these teams are kind of gelling together. And quite honestly, one of the things that we're just doing is these teams are actually, you know, on a Scrum team together. So they might not have the same reporting chain necessarily, but they are working more on a sort of a Scrum together with a common end goal, as opposed to it being sort of that proverbial handoff. Okay.
You mentioned automated testing. Have you eliminated all your functional testers?
Oh no, not at all. If I didn't reiterate it enough, our test coverage is extremely low, so we have a long time before that happens. Honestly, I don't know that that'll ever be something that just disappears, right? Because, you know, I don't foresee that happening, and not just, you know, our company. I think just in general. Anybody else?
So do you have you mentioned you have a self-healing cloud deployment. Do you have a Jenkins job that's doing a self-healing Jenkins server as well?
No, but that would be pretty amazing.
So what happens in your environment if your Jenkins server goes down, and then do you have any PR plan for that? Because it sounds like it's a pretty integral part of your system.
Yeah, so right now it's multi-AZ from a deployment perspective, and then the snapshots are what we are using for a DR thing. So it's a point-in-time job configuration snapshot. But I like that idea. I'll have to explore that. Yes.
Yeah, so you mentioned like unit testing and functional testing. How do you fit load testing into that flow?
We actually do have some performance testing tools. They're not quite at the maturity level that I'd like them to be at, but we do have a process that we're thinking through in terms of being able to kick off a job that could do a load test automatically as well, as like an on-demand thing. Yeah, absolutely. Okay, well, thanks a lot. Appreciate it.